So yesterday we have seen some basics of chain surveying. Today let us see what do we mean by ranging and what is an offset and what are the obstacles in chaining. So if at all when you are doing the chaining process in the field, if there is any problem in executing because of the natural surfaces of the ground, then how to proceed further. Those things will be seen. So ranging is nothing but it's the process of establishing intermediate points on a straight line between two endpoints. Suppose if you want to determine what is the distance, if you want to measure the distance between two given points A and B which are far away and which is more than one chain length, that is either the distance between A and B is more than 20 meters or 30 meters, wherein it involves multiple chains, then how to ensure that we are measuring the distance in the straight line only. So that process is generally called as ranging. So what we'll be doing here is this figure you can see this is station A and this is station B, and I want to measure what is the distance between station A and B. So which is consisting of three chain lengths. So total the distance may be either 60 meters or 90 meters depending on the chain length which you are using. So what we need to do here is you need to first establish your station points A and B. You need to drive the pegs there and you need to place your ranging rod. Okay. So once you place your ranging rod, you need to ensure that both are in one line. Okay. So what you need to do is you need to step back about a meter length. Okay, from here to here. Suppose if this is the ranging rod position, then you should never stand and see. Okay, because what happens is as the ranging rod height is about 2 to 3 meters, because of the effect of the wind, sometimes the ranging rod gets inclined. It will not remain perfectly vertical. Or if a peg is not driven in the ground and ranging rod is not fixed to it, if a person is handling the ranging rod, he may not hold the ranging rod perfectly normal or perfectly perpendicular to the ground surface. There may be some inclination. So that is the reason why most of the cases what we generally suggest is you move back about a meter or 2 feet from the position where you have kept your first ranging rod, bend down on your knees and check the bottom of the ranging rods, whether the two bottom of the ranging rods are in line or not using your eyes, using your naked eye. Okay, if you stand and check whether the two ranging rods in line or not, it's highly impossible for you because definitely there will be effect of the wind. Definitely the person who is holding the ranging rods may not perfectly hold the ranging rod. Okay, so that is the reason why we need to just bend down and check whether the bottoms of the ranging rods are in one line or not. So once you establish that that in that manner at the two stations A and B, then in between the station points A and B also you can fix the ranging rods in the same technique. So another person will be holding the ranging rod at an arm length. Okay, and based on the directions given by the person standing at station A and station B, the other third person will move the ranging rod till the ranging rod 3 also comes in line with ranging rod 1 and 2. Similarly, ranging rod at position 4 will also be fixed. So why we need to do this ranging purpose? Any rough answers from you people? Why ranging
To
is
align a
important?
straight line, sir.
Only to align a straight line?
Sir, to check the correctness of the work, sir.
Check the
Correctness, accurate. Whether we are going in a straight line or not.
only straight line?
To establish points, sir.
Intermediate point, sir.
Establish intermediate points is right, but why? You can establish intermediate points just by naked eye also, right? What is the purpose of
If
it?
it may long distance means it difficult, no, sir.
Long distance is difficult. At the same time, if your ranging is not perfect, assume that if these 2 points, this line endpoints are not fixed. Okay, that is, if you have kept a ranging rod at station A and then you have kept a ranging rod at B, then at C, then D, like at these positions, like this, if you keep on going, if it is not in straight line, if you're not ranging it properly, then this point may come up to this point. Now assume what is the area of this rectangle and what is the area of this one. you want to calculate the area of this polygon, it will be definitely more than the area of a regular polygon, regular rectangle. So it's not only for the purpose of establishing the intermediate points in between two given station points, it's also to ensure that whatever calculations you're going to do after establishing the points in the ground are not wrong. Okay, are you getting my point here? Actually, the point, the line should be at this point. But if you don't do ranging properly by fixing the station points A and B, okay, then the line point B may come here. Then what is happening? Some extra portion, this small triangle which you are able to see, that area, extra area will be coming into picture. Okay, so instead of measuring 1 acre of land, you may measure 1 acre, 1 gunta or 1 acre, 2 guntas land like that. Okay, the purpose is not only to establish intermediate points along the long edge, straight lines or long edges. It is also required to ensure that whatever the area calculations you are going to do after establishing the main survey lines, main survey points in the field, okay, that is also the requirement of doing the ranging. So when the two points are intervisible to each other, when the two endpoints are intervisible to each other, then simply you can go for direct ranging. Okay, but when the 2 points are not intervisible, that is when you're standing at A, you're not able to see the point B, or when you're standing at B, you're not able to see the point A, then we need to go for the indirect ranging. Okay. So in the direct ranging, you can see there are 2 points A and B. So the ranging rod at A is fixed and the ranging rod at B is also fixed. Another person holds the ranging rod at C, and based on the instructions given by A person standing at A and B, he will be moving the ranging rod towards the left hand side or towards the right hand side till the person standing at A confirms that the ranging rod position of the ranging rod at C is completely in line with A and B. That is, the person standing at A will be able to see both B and C, and he should, like, if the ranging rod is kept at C, then the person should not be able to see the point if the ranging rod kept at B, because both will be in the same line. Okay, so in this fashion we do the direct ranging. So it's a easy process, but it all depends on how slowly you are moving the ranging rod till the accuracy is obtained. But in the indirect ranging, you can see in this picture, if the person who is standing at A will not be able to see the person standing at B, because there is a higher elevation in between. The person standing at B cannot see A, but the person who is standing at A at C can see the person standing at A and also can see the person standing at B, and person who is standing at D can see C and B, but he cannot see A, or he may also see A. So in these scenarios where there are some obstructions or where there are some changes, sudden changes in the elevation of the ground surface, generally we go for the indirect ranging or reciprocal ranging techniques. So what we'll do in this is, okay, this is the plan of that before figure. I want to establish two intermediate points M and N between the given station points A and B. Okay, so what I will do first is, I'll identify 2 points. I'll move towards either one or towards the left hand side or towards the right hand side of the given line AB, to such a distance that from where I am able to see both the positions of A and B. So in this scenario, person at A is not able to see the person at B, or the person standing at A is not able to see the ranging rod at B. Vice versa, person standing at B is not able to see at B. So I have selected 2 points. Okay, M and N, I am selecting 2 points from where I am able to see all the points. So what I'll do is, one person will move to this point M1, okay, such that from M1, person standing at M1 is able to see the point A and point B. Then he gives, the person who is standing at M1 gives instructions to another person, okay, to stand at position N2, okay, such that N2 is in line between B and M1. At the same time, the point A and B are visible from N2. Okay, so person standing at M1 and N1, M1 is going to instruct N1 to move up to N2 till the point N1. The person standing at N1 and the person standing at M1 and the person standing at B are in the same line. Once this N1 reaches to N2, Then the person standing at N2 gives instructions to the person standing at M1 to move towards the line such that this M2A and N2 are in line. So in the first scenario, we are ensuring that B N2 M1 is in line. In the second step, we are ensuring that N2 M2A is in the line. Then the person who is standing at M2, which is in line with A and 2, will instruct the person N2 to move towards N3, that is towards nearer the side of the line, till again M2, N3 and B are in line. That is, we are doing a direct ranging here. M1, N2, B1 is a direct ranging. N2, M2, A is direct ranging because both these endpoints are visible to each other. Okay, so simply by using your naked eye, you are able to say, you're just adjusting the ranging rod and you are able to say that A, M2 and N2 are in the line. So in that fashion, you need to move towards the line, required line A and B. Okay, after 2 to 3 iterations, you will be able to ensure that the person standing at N3 will reach the point N, and M3 person will reach the M point, which will be on the line A and B. But this is the concept behind the indirect ranging or reciprocal ranging. So where it is not possible for us to see the two endpoints, we are going to identify 2 more intermediate points from where we are able to see the 2 endpoints, and we are going to move slowly towards the actual required line A, B. Okay, so this concept is called as indirect ranging. There are some signals which you need to use for ranging processes. Okay, rapid up and down movement with right hand and right side, move considerably to the right side. Actually, a good surveyor, the basic principle or the basic concept of surveying is a surveyor should not open his mouth in the field. Okay, he should only give instructions through his hands. Okay, for the person who is executing the work. If I'm standing at the person, if myself I'm standing at the position A and I want to give the instruction to person M1, M2, M3 or N1, N2, N3, I should not open my mouth. I should give the signals only with the help of the left hand or right hand in various positions. Okay, so if I'm moving my right hand up and down towards the right side, I'm giving an instruction to the person who is holding the second ranging rod that move considerably to the right side. Okay, if I'm moving the right hand with a slow up and down movement, I'm asking him to move slowly towards the right. And if the right arm is extended completely, so it's an indication that move continuously to the right. Right arm up and move towards right. Make the rod vertical by moving towards right. Rapid up and down movement with left hand and left side of the body. Move considerably towards the left. The first 4 are repeated in the 5, 6, 7, 8. Only thing is they are towards the left hand side and the first 4 are towards the right hand side. Okay, and when your both hands are made up and then brought down, then you're giving an indication to the assistant that the position where he is holding the ranging rod is the correct position. When both of your hands are brought forward horizontally and depressed, then you are giving an indication that fix the ranging rod at that position. So there is a small difference between the point 9 and 10. When both hands are made up and down or made up then brought down, you are giving the instruction to the assistant that the position where he is holding the ranging rod is correct. When it is brought forward horizontally and brought down, okay, then you are giving an instruction, fix the ranging rod there. You have identified the correct location, please fix the rod there. So it's simple, just moving your hand fastly towards the right hand side, slowly towards the right hand side. That indicates that you need to move towards your right hand side. A fast movement or a slow movement towards using your left hand, if you are giving an instruction, it indicates that move towards left hand side either slowly or fastly. Okay, then raise your hands up and bring down. It indicates the position is correct. Move your hands forward and then depress it. It indicates that you need to fix the ranging rod there. So this is how you need to give the instructions. These are all the figures are already available in your textbooks. You can refer them. Okay, or we are planning to share you the recordings of lab lectures also. In that also we'll be showing you how to give instructions to your fellow mates. Okay. Then I'll move to offsets. What is an offset? I think this is a basic definition which you already studied. What do you mean by an offset?
To fix the perpendicular.
Small distance.
It is a lateral distance of any object from the chain line. Okay. From this figure, you can see there are two endpoints A and B. This is the main chain line. If I want to establish or mark or determine the position of an object from the chain line, so the bottom of this object is called as the offset. Here you can see D1 and D2 distances are there. These are the distances of the offsets, and these are perpendicular offsets. If I want to determine at what distance this tree is available from the chain line. I want to determine at what distance this flagpole is available from the chain line. Okay, so these lateral distances from the chain line are called as an offsets. So these are used to establish the points in the field or to determine the position of the points available in the field from your main chain line. So there can be multiple types of offsets. One is perpendicular offset, other is oblique offset. A perpendicular offset is nothing but which is making an angle of 90 degrees with the main chain line. An oblique offset is nothing but it is some at an inclined angle other than 90 degrees. This figure you can see the corners of this building or this rectangular block, okay, they are inclined at an angle. They are not at right 90 degrees. But if you take the example of this tree and flagpole, they are at 90 degrees to the chain line. Okay, so how do we measure these offsets? Any instruments which you have left in your.
Cross stuff.
Offset rod. Offset rod.
Cross stuff, sir.
So there are multiple instruments. One is the basic instrument which we use generally is the cross stuff, and we can also use a prism square or an optical square. Okay, and if at all these three instruments are not available, then you can also use a normal tape. Okay, so using a normal tape also by the mechanism of swinging, you can set an offset in the field. So what we'll be doing here is you'll be holding one end of your tape at the foot of the object. If I want to determine what is the offset of this, I'll carry one zero mark of the tape at this point, and I'll expand the tape. Other person will expand the tape and he'll move towards the chain line, and then he tries to swing it. Okay, ఇక్కడ ఒక పాయింట్ ఇక్కడ ఒక పర్సన్ పట్టుకొని ఉంటాడు స్టార్టింగ్ పాయింట్ ఆఫ్ ద టేప్ ఎక్స్టెండ్ చేసిన తర్వాత మళ్ళీ ఇంకొక పర్సన్ దాన్ని పట్టుకుంటాడు. హీ విల్ మూవ్ టువర్డ్స్ ద టేప్, హీ మూవ్ టువర్డ్స్ ద చైన్ లైన్, and he tries to swing in this direction. So wherever he gets the minimum distance, that is defined as the perpendicular offset. From this figure, it is self-explanatory. If you are in this direction, it's a slant height. Here also it is a slant length or slant height. Only here it is the perpendicular, and the distance will also give you the distance also gives you an indication that this is the perpendicular offset. Wherever it touches the chain line, that is going to define the foot of the perpendicular offset. This is a simple technique which is used whenever you don't have any instrument such as optical square or a class staff. But most of the cases we avoid this because we have a simple set of instruments. This is a class staff you might have already used. The colors may be different, but it is a square prism, or it's a square prism having two slits at the top, through which are at 90 degrees to each other, and it is fixed to a iron rod or a steel rod at the bottom. So what you need to do here is you need to move to approximately where the object is existing in the field along the chain line, and you need to place this rod up in an approximate position, and you need to see the object. If you want to determine the position of the tree, okay, you need to place this full grass staff on the chain line approximately, because using your common sense and using your naked eye, you can say where can be the possible offset. So move to the approximate position, fix it on the chain line, keep this offset rod on the chain line, and try to see through this slit, this one. Okay, if you are able to see the object, or if you are able to see the object through this slit, then ask another person to check through this slit whether the ranging rod which is kept at the point starting point A and ending point B is visible to him or not. If when I am able to see through this point and the other person is able to see through this point, the two objects, the starting point A as well as the object for which I'm marking an offset are visible, then that position will give you the foot of the perpendicular. If not, you need to move this instrument towards the right hand side or left hand side till you are able to see both the features perpendicular to each other. It's such a simple technique. So first one person will be seeing through this slit, another person will be seeing through this slit. Once he checks through this direction towards left to right, again he moves towards this side, and he checks from the right to left side to see the ranging rod at B. If all these three are visible through these two slits from the position where you have kept the crash staff, then we say that it is the perpendicular foot of the perpendicular offset. If not, you'll just try to move the cross shaft slowly towards the left hand side or towards the right hand side till you're able to get this scenario. Okay, so there are multiple types of cross shafts. The basic cross shaft is the open cross shaft, which is used to set the offsets at an angle of 90 degrees. Only 90-degree right angle offsets can be done, or perpendicular offsets can be fixed using this instrument. There is one more cross shaft, which is French cross shaft, which is used to set offsets at an angle of 45 degrees. There is nothing but your oblique offsets. An adjustable cross shaft is used to set offsets at at any angle from 0 to 360 degrees. So these are the three basic types of cross shafts which are available in the industry right now. But most of the cases we again generally go for with the simple cross shaft or open cross shaft. In our lab, we have only the open cross shaft. So we are going to establish only the perpendicular offsets in our lab. Okay. Another advanced instrument other than this crash shaft, the possibility of making an error in using this crash shaft is very high, because when you are seeing through the slit, you will close eye, you'll close one of your eye and you'll try to see with the other eye. So there is a possibility of parallax coming into picture. And when you are seeing, there is a possibility that you are not holding the crash shaft rod perpendicularly also. There may be some inclination. ఓకే, మనం లూజ్ గా పట్టుకున్నా కానీ లేకపోతే సరదాగా పని చేస్తున్నప్పుడు పక్కనోడు మనం గెలికినా కానీ అది పర్ఫెక్ట్లీ పర్పెండిక్యులర్ ఉండదు. సో దెర్ ఇస్ ఎ పాసిబిలిటీ ఆఫ్ మేకింగ్ సమ్ ఎర్రర్ హియర్. సో in order to counter that, what happened is we are using optical square and prism square, where the function of this prism is the same technique. What you going to implement is the same technique of your crash shaft. Okay, instead of a crash shaft, you are going to have a prism wherein you are going to get the images of A, B, C, D in the prism. So I'll hold the prism square, or I will hold the optical square at approximate position on the C, at the position C. Okay, when I when I place this instrument at point C, okay, the rays which are coming from A will try to provide an image. The rays which are coming from B will also try to provide an image in the prism. Okay, so and the rays which are coming from the point D will also be reflected in the prism. If all these three are perpendicular to each other, you'll be getting a single line. The position of D, you can see from this figure, position, the image of the D and the image of A, B will come in the same line. If it is not perpendicular to each other, you'll be getting a variation. So like this, in this first figure, you can see D is at some position, A is at some position. But the requirement is both the images of A, B and D should coincide and should be one above the other. So what I need to do is, once if I place the optical square or prism square roughly at the position C by approximation, I will be getting this image. So based on these images which are coming into this instrument, I need to again slightly move the instrument towards either left or right or like this in either of the directions till these two images coincide. Once these two images coincide, then the bottom of that point, okay, I will just drop the center point of the prism square instrument using a plumb bob onto the ground. Wherever the plumb bob touches the ground, that defines me the perpendicular foot of the perpendicular offset. So here the chances of making errors is less, because the reflection is coming from the ranging rods, that is converted into an image, and you are able to see whether the two images are coincided exactly or not. But in the case of an open cross shaft or adjustable cross shaft, what is happening? It is purely dependent on the human perception. So there is a possibility of making errors there, but there is no possibility of making any errors here in when you are using an optical square or a prism square. So that is the advantage of this optical cross shafts. Okay? But no doubt, whenever you are doing any work in change surveying, by default you will be having offsets. Okay, instead of your trees and flagpoles, if you are having multiple buildings, if you want to measure, if you want to plot the building shape, etc., kind of thing, then definitely you need to measure the distances. Suppose for example this is your building, okay, then definitely you need to measure what is the distance of this from here to here. Similarly, you need to measure the distance of this from here to here. Okay. So these are all the outer boundaries of your objects will be obtained only with the help of your offsets. So offsets are very, very important and the basic things in your chain surveying. Okay. Next, we'll move to obstacles. What do we mean by obstacles? What type of obstacles do you find in chain surveying. Normally, what is an obstacle? What is an obstacle?
which makes us uncomfortable to do the work.
Addu, sir.
అడ్డం రావడం సార్.
అడ్డం ఉంది. So what you'll do?
We try to remove the or we'll deviate, sir.
You deviate. So in what way you will deviate?
Either moving our chain work on other side or moving the obstacle.
So if you take any civil engineering project or any surveying project, we can't expect that everything will go smoothly, right? That is a basic thing which all of us should know. Not only any civil engineering project, even in our lives also nothing will go as per in a smooth manner. So we also face some problems in our lives. So what we'll do, we'll try to find out what are the other alternatives, and then we'll try to solve the problems. In the same fashion, in the chain surveying also, or in any type of surveying also, there is every possibility of some obstacles in our day-to-day works, in our calculations, etc. kind of thing. So we need to identify some other alternative. We can't stop the work. We need to complete the work. So we need to identify if at all there is any obstacle, we need to identify what is the other possible alternative, then do our calculations. So in chaining surveying, we have very simple obstacles, okay, wherein there is a possibility of chaining free and vision obstructed. That is, you are able to do the chaining process, you are able to drag the chaining process, but vision is obstructed. That is, you are not able to see the point A from B, point B from C, from like that. Okay, both the endpoints may not be visible to you, but you can drag your chain on the ground without any problem. That is one type of obstacle. Another one is chaining obstructed vision is free. Okay, wherein you are not able to continue the chaining because of the presence of a pond or because of presence of valley, etc. kind of thing, but you are able to see the two opposite points. From A, you will be able to see the point B. From B, you will be able to see the point C or A. But you can't drag the chain because of presence of a pond or because of a presence of a boulder or because of presence of a valley. And the third choice is both chaining and vision are obstructed. You can't do the chaining along the line, required line, and you are not able to see both the endpoints. Okay, so these are the three possibilities of obstacles in chaining. So we can't stop work or we can't avoid the work. We need to ensure that the work is completed and the final report is generated. So how do we solve that? These are very simple basic techniques we are going to learn here using your geometric principles which you have learned in your schooling only. Okay, this is one possibility of chaining free and vision obstructed. That is, I can do the chaining. Okay, so this is assume that this is a boulder, okay, or some higher elevated ground from where I'm not able to see. When I'm standing at A, I'm not able to see the point B, and vice versa. But I can do the chaining adjacent to this. So what I'll do is I will draw a line. I will chain a line from A to B dash, such that from B dash B is visible to B. So I can measure the distance AB dash from A to C dash, assume that it is one chain length, from C to D, C dash to D dash, another chain line, second chain line, D dash to B dash, third chain line. And I can also measure BB dash using the chain again. Let us assume that this is also one more chain line, 20 meter, 20 meter, 20 meter. So what I need to actually measure, what is the actual distance between A and B I want to measure. But there is an obstruction here in the form of a CD. So in order to solve this problem, what I am doing, I am moving away from the chain line AB such that, and I'm going to identify point B dash such that from B dash I'm able to see the point B as well as I'm able to see the point A. Okay. After identifying this point B dash, I'm going to measure what is the distance between AB dash. Also, I'm going to measure what is the distance between B dash B. Once I measure these two distances, can I measure this distance AB? Using your simple Pythagoras theorem, AB square is equal to AB dash square plus BB dash square. I hope you all know all these equations, right? Pythagoras theorem తెలుసు కదా?
ఎస్ సార్.
Okay. So from this figure, it is a right angle. So I can apply the Pythagoras theorem. This is my hypotenuse. AB square is equal to AB dash square plus B dash B square. I am measuring this distance AB dash in the field, so I can replace that value. I am measuring B dash B in the field. I can substitute that value. So if I add these two values and take the square root, I am going to get the distance AB. So this is an indirect method. as I'm having a problem in continuing the chaining from here to here because of the vision, because of the obstructed vision, I'm moving towards the left hand side or towards the right hand side. I'm trying to find out using some geometric principles. Okay. In the similar way, this is one more case. Okay, where there is this water is available in between. So I want to determine what is the distance between A and B, which are on either side of the water. So what I'm doing, I'm taking a perpendicular at A. I'm identifying a point C. I'm also taking a perpendicular at B. Point D I'm identifying. Okay, and I'm going to measure the distance CD, which is definitely equal to the distance AB because these two lines are perpendicular to each other. So the distance CD is definitely equal to AB. Okay, I'm measuring AC, I'm measuring BD, then I can measure the value of CD, which is equal to AB. This is one more technique. And another technique is I'm dropping a perpendicular at A and I'm identifying a point C from where I'm able to see the point B without obstruction. Okay, so again, this is 90 degrees. I can apply the same Pythagoras theorem. AC square plus BC square is equal to AB square. Okay, this is one more technique. So what you need to do is in solving the problems, when you need to first draw the diagram. Okay, based on the given data, you need to draw the diagram. And after that, using your geometric principles like this Pythagoras theorem or cos theta, sin theta, cosine rule, etc. kind of thing, and you need to determine what is the unknown length. Okay, what is the cosine rule? What is cosine rule? Okay, so you need to remember those equations. Okay, and I hope you also know some other equations, opposite side by opposite angle, all those things. Sin AB by sin C is equal to distance. AB by sin C is equal to BC by sin A is equal to CA by sin B. Okay, so you need to have the idea of those cosine rules and sine rules, but most of the cases will be using the cos rule only. Okay, so this is one more technique where there is an obstruction. So I'm dropping a perpendicular from A to C and B to C also I'm dropping a perpendicular. So again, this unknown AB can be measured by indirectly by because I'm measuring AC, I'm measuring BC. Okay, by using these two lengths, I can measure AB. And this is one more possibility wherein I'm identifying a point C and I'm going to extend that point C up to E such that CE distance is equal to AC. Similarly, I'm going to measure the distance from B to C and I'm going to extend from C to D. Again, CD is equal to BC. So then the distance DE will be definitely equal to AB because these two triangles ACB and CDE are congruent. Okay, this is one more possibility. And this is one more possibility where you want to determine the width of a river, where it is not possible for you to drag the chain in the river. So what we'll be doing here is we'll be identifying 2 points on any side of the river, and from that points we will dropping a perpendicular. This is AD, we are dropping a perpendicular, and CF also we are going to drop a perpendicular, and we are going to extend this CF up to E such that the point B, which is on the other side of the river, and point D and point E are in the same line. Okay, so I'm going to draw a diagram like this. Then using these equations, I can determine what is the distance of AB. See, from these triangles, you can see AB by AD from the concept of similar triangles. From the triangle ABD, AB by AD is equal to, this is also a similar triangle, okay, DFE. ABD and DFE are similar triangles. So from this triangle DFE, DF by FE. So AB by AD is equal to DF by FE. Okay, but DF is equal to this portion, this is equal to this portion because these two are perpendicular. So distance DF is definitely equal to distance AC. So I'm substituting that AC here, DF, and FE. What is FE? FE is equal to this portion. This total portion is CE. CE minus CF will give you FE. But what is CF? Again, it is given as AD. Okay, I'm just rearranging this equation here. So AB by AD is equal to AC by CE minus AD. So from that, if I again rearrange it, AB is equal to AD into AC by CE minus AD. Okay. So there is no need of calculating or measuring FE. So simply by measuring AD and AC, you can determine what are the other values. Okay. So you need to use your brain in drawing the diagrams. The diagram will not be given to you in the question. Only the data will be given to you in the question. Based on the given data, you need to think and draw the diagram properly. Then you need to solve these kinds of problems. Okay. So like this, there are many possibilities. Okay. So we'll try to solve one problem. I'll explain you once. Because I hope you have covered this in your diploma, right? చెప్పారా ఈ obstacles problems
Yes,
డిప్లొమాలో?
sir.
చెప్పారా అమ్మా?
Yes, sir.
లేదా? So then better
Late, sir.
you try to note down this problem first. Question రాసుకోండి. Then I'll explain you the procedure. First note down the question, which is in red color. There is an obstacle in the form of a pond on the main chain line AB. 2 points C and D were taken on the opposite sides of the pond. On the left of CD, a line CE was laid out 100 meters in length and a second line CF 80 meters long was laid out on the rights of the CD, such that ED and F are in the same straight line. ED and DF were measured and found to be 60 meters and 56 meters respectively. Find out the obstructed length CD. Please confirm me once you have noted down the question. You'll be given only this data. You'll not be given the diagram in the exams. ఈ డేటా ఒకటే ఇస్తారు మీకు. If you have noted down, I'll continue. రాసుకున్నారా?
Yes, sir.
So this is the question given to you. So let us try to draw the diagram now. So what is the step? First step given here is saying that there is an obstacle in the form of a pond on the main chain line AB. So first draw a main chain line AB. So this is your point A, and this is your point B. Okay. So what is saying? There is an obstacle in the form of a pond on the main chain line AB. So assume that this is your obstacle. Okay, this is the pond. So 2 points C and D were taken on the opposite sides of the pond. So he has taken 2 points on the opposite sides. So let us take this point as C, and let us take this point as D. Okay. On the left of CD. Okay, 1 second. Yeah. On the left of CD, a line CE was laid out. 100 meters in length. Okay, which is the left of CD? This is C. This is D. Which is left of CD? So from here to here. So he has laid out a line here. Okay, such that the distance was 100 meters. So let us assume that this point is E, okay, as per the given question. Then what is given? A second line CF 80 meters was laid on the right of CD. So from C, he has taken another line CF, which is 80 meters distance. But what is the condition he has given in the question? On the left of CD, a line CE was laid out 100 meters in length, and the second line CF 80 meters long was laid out on the right of CD such that E, D, and F are in the same straight line. E, D, and F. Where is E? This is E, this is D, and this is F. These three are in the same line. So this point should come here because E color D, it is C, intersection C, this intersection is D. So this D, E, D, F are in the same line, same straight line. ED and DF are measured and found to be 60 meters and 56 meters respectively. So he has given you the distances here. ED, this distance is 60 meters. He has given you the other distance. This is 56 meters. And he has given this value as how much? 100 meters, this one. He has given this another value, that is how much? This is 80 meters. So this is the given information. The whatever information is given in the question, that is converted now into a diagram form. Now what we need to determine? We need to determine the distance between C and D. Okay, we need to determine distance between C and D. So how to solve this problem now? Assume that this angle is theta. Okay, assume that this angle is theta. I don't know whether I can insert symbol here or not. Symbol equation on the symbol ledu. Okay. So assume that this angle is theta. Then from this figure, what is cos theta? One second. So this is your theta value. So from this figure, from triangle FCE, okay, from triangle FCE, cos theta is equal to, as per your cosine rule, what is the equation? FC square plus FE square minus CE square divided by 2 times of FC multiplied by FE. Do you all accept with this equation? Cosine rule is equal to square of two adjacent sides minus square of the opposite side divided by 2 times of multiplication of adjacent sides. So if I'm taking this triangle FC whole triangle, if this is cos theta adjacent sides is FC square plus FE square minus CE square is the opposite side divided by 2 times of FC multiplied by FE. Okay, so this is the equation. This 2 here it is nothing but square amma. Ikkada symbols పెట్టడం కొద్దిగా కష్టంగా ఉంది నాకు, అందుకని ఇట్లా రాస్తున్నాను. So substitute in this equation now. What is FC value? 80 square. So I'll write it as 80 by 80. 80 multiplied by 80 plus FE is 60 plus 56. How much?
116.
116 multiplied by 116 minus E is 100. 100 by 100. So I'm just substituting these values and divided by 2 times of FC is 80 multiplied by 116. Okay, please calculate and tell me the value.
0.531, sir.
Remaining any other one, please confirm the answer.
0.531.
Any other person can please can you confirm the whether you got the same 0.531?
Sir, 0.531.
Any other?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, right. Then now again from triangle FCD, this triangle, from triangle FCD, what is cos theta value? What is cos theta equation from this triangle FCD, this one?
FC square plus FD square minus CD square by 2FC
Square plus FD
FD, sir.
square minus CD square divided by 2 times of FC multiplied by FD, right? Correct na equation?
Yes, sir.
Yes,
So
sir.
substitute the values. What is FC value? 80 multiplied by 80. What is FD value? 56 multiplied by 56 minus what is CD value? CD is unknown, right? Okay. Divided by 2 times multiplied by FC value is 80 multiplied by 56. So tell me what is cos theta value? 0.531. Pine meer calculate chesaru kada. Okay. Now tell me the right hand side value. 80 by 80 plus 56 by 56 minus CD square by 2 into 80 into 56. What is the value? So if I'm rearranging this equation, 0.531 multiplied by 8960, this is equal to 9536 minus CD square.
69.12.
So 0.531 into 8960, 0.531 into 8960 is 4757.76. This is equal to 9536 minus CD square. So bring the CD square towards the left hand side and 4757 to the right hand square. I'll get CD square is equal to 9536 minus 4757.76. So 9536 minus 4757.76. The value is 477824.
778.24.
Yeah, so what is the value of CD now? CD is equal to square root of
69.12, sir.
69.124, sir.
9.124 meters. So what is asking you to calculate? Find out the obstructed length CD. So you have determined the value of CD, 69.124 meters.
69.112, sir.
Yeah, my answer is 69.123. Not a problem. After decimal, you will be definitely getting some variations. Okay. So this is how you need to draw the diagram. You need to convert the given data in the question into diagram format. Then you need to use your cos tools or any trigonometric rules or Pythagoras theorem and determine what is the value. So I'll give you one simple question now. You need to solve that and tell me the answer. Okay. So I'm only showing the figure here, but okay, not a problem. Try to solve this. Note down this question, all of you. And find out what is the distance AB. The position of alpha is also shown in the figure. The values, the distances between AL, AM, MB, and BL are shown here. So find out the distance AB. Have you noted on the question? So what is cos alpha equation for this figure? Are you there? Yeah, what is the cos alpha equation?
Yes, sir. Square minus 901 square by 2 into 1100. 2 into 1100 into 10, 1050, sir. If we calculate that,
Cos alpha is equal to 1100 multiplied by 1100
plus 1150, 1050,
plus 1050 multiplied by 1050
minus 901 square
minus not 1 into 901
by 2 into
by 2 times of 100 multiplied by 1050, right?
yes, sir.
Yeah, what is the value?
0.649, sir.
గట్టిగా చెప్పండి అమ్మా,
0.649.
ఇవ్వట్లేదు. 0.649.
Yes, sir.
Remaining people, please confirm whether you got the same value.
Yes, sir. 0.649. 489.
64.
Sir, 0.649, sir.
Okay, this is from triangle MAL, right? Okay. Now from
0.6.
okay. Now from triangle MAB. Okay. What is the value? 0.649 is equal to, what is the equation?
110 square plus 548 square
700 into 1100 plus 548 into 548
548 minus
minus
AB square.
AB into AB, okay, divided by 2 times of 700 multiplied by 548. So what is the value?
Sir, 853.15 వచ్చింది సార్ ఆన్సర్.
Remaining people, please tell me what is the answer of AB?
Sir, 853.152, sir.
853.152.
152.
Others, any others, please respond. I got the answer as 852.66.
Yes, sir.
The angle is 0.6497. I got. Got the angle as 0.649. Okay, it's okay. Six four nine seven 649. Okay. Others, please respond whether this answer is correct or not. తొందరగా చెప్పాలమ్మా.
Yes, sir. Correct, sir.
Correct? So this is how you need to calculate. So there is a small slight difference in my answer and your answer. I got a 852.66 and you got a value of 853.152. Doesn't matter. It may be because of you are using calculators and you're not cutting short the value directly. You're multiplying or adding. There might be some decimal.
No, sir. You have taken another decimal, sir.
Another decimals. Okay. So not a problem. So this is the procedure. Follow the
Taken 4
procedure and
decimals.
yeah. Okay, not an issue because angle value you got the right thing, right? I have taken 0.6497. You have taken the angle as 0.649. I have taken one more decimal extra in my problem. So it doesn't matter, but have you understood the concept how to solve? That's important. Okay.
Yes, sir.
So let us do one more typical problem. This question is not available with me. Okay, we'll see tomorrow. Not a problem. Okay, one more problem we'll try to solve. This is another different problem. This is another kind of problem where to continue a survey line AB past an obstacle, a line BC 200 meters was set out perpendicular to AB, and from C angles BCD and BCE were set out at 60 degrees and 45 degrees respectively. Determine the length of which must be chained off along CD CE in order that ED may be in AB produced. Also determine the obstructed length. You please see the question carefully. He is saying that while you are doing a survey for a line AB, okay, and there is an obstacle after B, okay. So to clear that obstacle, what he is saying is that B is dropping a perpendicular BC of 200 meters length, and from C he is identifying 2 points E and D such that angle BCE is equal to 60 degrees and angle BCD is equal to 45 degrees. BCD is equal to 60 degrees and BCE is equal to 45 degrees respectively. So he's asking you to determine what is this length and what is this length such that the point E and D are in the line AB extended. AB ని extend చేస్తే అదే లైన్ మీద ఈ పాయింట్ E and D రావడానికి ఈ లెంత్లు ఎంత ఉండాలి అన్నది క్వశ్చన్ లో అడుగుతున్నారు, CE and CD. And also is asking you to determine the obstructed length. Obstructed length is nothing but BE. Here you are having an obstruction, so you need to determine what is the length of BE. So it's very simple. From this diagram, if you can see, you are having two triangles BCE and BCD. Okay. So how to calculate the value, estimate the value of CE and CD is what is asking you. Okay. I hope what is you know tan theta and sec theta etc. kind of things. Okay. So if you want the length of CE from this triangle BCE, what is sec theta? Secant theta ante enta value. Opposite by adjacent, adjacent by opposite, adjacent by hypotenuse, opposite by hypotenuse, hypotenuse by adjacent. Enti equation.
Hypotenuse by adjacent, sir.
Hypotenuse by adjacent. So from this triangle BCE, what is sec 45? Angle is given as 45. What is sec 45 now? Sec 45 is equal to CE is hypotenuse for this, right? Okay. CE is hypotenuse, adjacent is CE. So sec 45 is equal to CE by BC. I know what is the value, but CE is unknown to me. So CE is equal to BC sec 45. BC value is given as 200. 200 into sec 45. You are getting an answer of 282.84 meters. Similarly, from triangle BCD, the angle is 60 degrees. So secant theta is equal to secant 60 is equal to CD by BC. So CD is equal to BC sec 60. 200 into sec 60, it is 400 meters. That is the second problem. And is also asking you to determine the obstructed length. Obstructed length is nothing but BE. I want to know what is the distance between BE and E. So from this triangle BCD, what is tan theta? Tan 45 is equal to opposite by adjacent. Opposite is unknown to me. BC is unknown to me. BC I know. Okay. So BE is equal to BC tan 45. 200 into 1 is 200 meters. Very simple problem. Okay. So you'll be getting problems like this, and you need to draw the diagrams, and you need to draw the diagrams correctly, and then you need to calculate what are the required parameters asked in the question. Okay. So please tell me your attendance.
Excuse me, sir.
Yeah.
Sir, one query, sir. Yesterday you said you will be inquiring about our exams, no, sir?
Yeah, it's in the last week.
Last week.
Last
sir.
week of December. Last week of November.
Okay.
Please tell me your roll numbers. 301,
Present, sir.
302, 303,
Present, sir.
304,
Present, sir.
306,
Present.
307,
Present, sir.
308,
Present, sir.
309,
Present, sir.
310, 310. మీరు అటెండెన్స్ చెప్తేనే వేస్తానమ్మా, లేకపోతే అబ్సెంట్
Present,
వేస్తాను.
sir.
312,
Present, sir.
313,
Yes, sir.
314,
Yes, sir.
315,
315 present, sir.
316,
Present, sir.
317,
Present, sir. 317.
318,
Present, sir.
319.
Present, sir. 319.
Okay.
Sir, ఇది నాకు
319.
What about other classes? What about other classes? Were they happening?
Yes, sir. We are listening with regular students, sir.
No, not regarding regular classes. Other classes for the first unit syllabus, first internal syllabus. Engineering mechanics, solid mechanics. I think industrial psychology is happening, right? Menka Madam and Nandan sir are taking. What
Yes,
about
sir.
energy science and engineering? Are classes happening for that?
Only one class happens, sir.
SM
Bhargav
Rupa
sir.
ma'am taken, sir.
Energy science and engineering.
Yes, sir. One chapter finished, sir. First chapter.
SM
Chapter
class
finished.
is going.
Mechanics, mechanics and geology,
Mechanics not yet started, sir.
geology.
Geology started, sir.
Start in the.
Yes, sir.
Okay. Okay then. Right.
ఓకే సార్ ఇంకో స్మాల్ ఇష్యూ ఉంది సార్. ఇది నాకు మెసేజ్ వేరే వాళ్ళది వస్తుంది సార్. ఇది 310 మెసేజ్ ప్రెసెంట్ అని నా ఫోన్కి నా మెసేజ్ రావట్లేదు సార్.
అర్థం కాలేదమ్మా.
నేను ప్రెసెంట్ అయ్యాననే అటెండెన్స్ నా ఫోన్కి మెసేజ్ రావట్లేదు సార్.
మీ నెంబర్ కరెక్టే ఉందా చూసుకున్నారా?
కరెక్టే ఉంది సార్. నా ఫోన్కి వేరే వాళ్ళ నెంబర్ ప్రెసెంట్ అని వస్తుంది సార్.
అవునా?
అవును సార్.
అంటే ఈయన నెంబర్కి ఆ పేరు.
సరే నేను చూస్తాను. అదే నేను చూస్తాను, ఎందుకంటే ఆ కన్సర్న్ మా చేతిలో లేదు, అది సెంట్రల్ టీమ్ ఉంటుంది దానికి కాలేజ్ లెవెల్లో. ఆల్రెడీ నిన్న ఎవరో ఒక అబ్బాయి అడిగితే నేను ఫార్వర్డ్ చేశాను. థింక్ 319 అనుకుంటా నిన్న నాకు రేజ్ చేసిన రిక్వెస్ట్.
Yes, sir.
అండ్ 310 కూడా రిక్వెస్ట్ చేస్తున్నా. ఐ హావ్ ఫార్వర్డెడ్ ఇట్ టు ద కన్సర్న్ పీపుల్.
Okay, sir.
వాళ్ళు అప్డేట్ చేసి మాకు రెస్పాన్స్ ఇచ్చిన తర్వాత నేను మీకు చెప్తానమ్మా. అండ్ యూ నీడ్ నాట్ బాదర్ అబౌట్
Okay,
యువర్
sir.
అటెండెన్స్. ఓకే,
Okay.
దట్ విల్ బి టేకెన్ కేర్ బై us. బికాస్ ఈసారి ఏమైందంటే ఎప్పుడు ముందే జాయిన్ అయిపోయే వాళ్ళు ఈసారి కొత్త ఎక్కువ మంది జాయిన్ అయ్యారు. యాక్చువల్ స్ట్రెంత్ 18 లాటరల్ ఎంట్రీస్, బట్ 33 జాయిన్ అయ్యారు. సో ఇంకొంతమంది స్పాట్ అడ్మిషన్స్ లో జాయిన్ అయ్యేసరికి రూల్ నెంబర్స్ కొద్దిగా అటు ఇటు షఫల్ అయిపోయినాయి. సో అకాడమిక్ సెక్షన్ కి సాఫ్ట్వేర్ సెక్షన్ వాళ్ళకి కొద్దిగా మిస్కమ్యూనికేషన్ అయ్యి ప్రాబ్లం వస్తుంది. బట్ వాళ్ళు సాల్వ్ చేస్తారు, ఎందుకంటే అడ్మిషన్స్ బిజీలో ఉన్నారు. వాళ్ళు సాల్వ్ చేస్తారు, మీరేం వరీ అక్కడ మీ అటెండెన్స్ గురించి. జస్ట్ ట్రై టు లిసన్ ద క్లాసెస్ అండ్ ట్రై టు అటెండ్ ద క్లాసెస్. ఓకే, అటెండెన్స్ విల్ బి టేకెన్ కేర్ బై. ఓకేనా?
సార్ ఈ 6 సార్ ఇప్పుడు అటెండెన్స్ పిన్ నెంబర్స్ అంటే ఈ పిన్ నెంబర్స్ సెక్షన్స్ పర్మనెంట్ సార్? అంటే ఐ మీన్ 6 సార్?
Yeah, permanent.
Mali change aitadi.
This is your hall ticket number. What I have sent recently, like updated rule numbers
Okay.
and పంపించాను కదా ఒక Excel. That is your final hall ticket numbers.
Yes, sir.
Okay.
Okay.
Okay then. Bye for the.
Okay.
Hello.
Hello.
రికార్డ్ అవుతుంది రా